All right, for this question, it's about rolling a die. But before we get to rolling the die, let's take a look at the big idea. The big idea is, well, first of all, it's about probability, which we've done. But more specifically, the big idea is about dependent versus independent events. Let me do some other probability questions to kind of show you the difference between the two. We'll start with flipping a coin. So I'm going to flip the coin. Let's say we're trying to get tails. What's the probability that when I flip the coin, it's tails? Well, it's either heads or it's tails, and half the time it should be heads, half the time it should be tails. The probability should be 1/2. And 1/2 because there's one side that is tails, that's where the 1 comes from, and there are 2 total possibilities, heads or tails, that's where the 2 comes from. So 1 out of 2. All right, so let's flip the coin. It's either going to be heads or tails. The probability it's tails is 1/2. It is tails, all right. Now I'm going to flip the coin a second time. What's the probability this time that it's tails? Now keep in mind, I already flipped it once, and it was tails. Is the probability of getting tails this next flip still going to be 1/2, or is it different now? Well, let's investigate. When I flip this coin this time, there are still 2 possibilities, so the 2 is still going to be the same. Is one of them still tails? Yeah, one of them is still tails, so the probability is 1/2 again. So it was 1/2 the first time I tried it, and it's still 1/2 right now. So the chances of this being tails is going to be 1/2. It was tails, how about that? So the probability was the same both times. That's an example of independent events. What happened here did not impact what was going to happen here. These were independent of each other. So if you recall, I got tails the first time I flipped it, but if I tried this again, and the first time it was heads, the second time would still be 1/2. So this does not get impacted by this at all. They were both going to be 1/2, independent of each other. Now check out this next experiment. We've got 3 markers in here. Okay, so 2 of the markers are black, 1 is orange. We're going to put them in here. So again, we got 2 black, 1 orange. Okay, so I'm going to close my eyes and randomly select one. What do you think the probability is that I select a black marker on the first try? I'm going to try it twice. So I'm going to try to get a black marker the first time and the second time. So what I'm going to do is I'm going to reach in, I'm going to grab one, I'm going to take it out, I'm going to set it aside, and then I'm going to try it again. So the probability that I select a black marker. Well, this time instead of the denominator being 2, how many total outcomes are there? Well, there are 3 outcomes. There's 3 different markers. Out of the 3, how many of them are black markers? Because that's going to be the numerator. So out of 3, I've got 2 black markers. I've got a 2 out of 3 chance. All right. Now check this out. So closing my eyes, got a 2 out of 3 chance I select a black marker. And I'm going to select this one. It is orange. All right, I'm going to set that aside. Now I'm going to try again to get a black marker. I set the first one I picked aside. So what is the probability now of getting a black marker on this next time? Is it still going to be the same, still 2/3? Well, now if you look, there are not 3 outcomes. There's only 2 outcomes. So this time, the probability is different. It's out of 2. And how many are black markers? Because that's the numerator. Looks like both of them are blue. That's 2 out of 2. That's 100%. I believe I've got a 100% chance of getting a black marker this time. Let's try. I'll bet you all the money in the world this is going to be a black marker this time because it's 100% probability, and it is a black marker. There we go. All right, so notice this probability was not the same as this one. It started out as a 2 out of 3 chance. Then it went to a 2 out of 2 chance. That's an example of dependent events. The probability of this depended on what happened here. Because I picked an orange one first and not a black one, that means the only thing that was left was black, and now the probability went from 2 out of 3 to 2 out of 2, 100% chance. Now, let's say I tried that same experiment, going back to the very first pick, where I had 2 black and 1 orange. I'm going to select one of these, I'm going to put it aside, and I'm going to try it again. What's the probability I get black? It's 2 out of 3. Now let's say when I had my eyes closed that first time, let's say I didn't select the orange one like what happened last time. Let's say I selected the black one. So my eyes are closed and I picked a black one and I set that aside. And now I'm going to try to get a black one again. What's the probability now? So last time we did this, the probability was 100% the second time of getting black. This time I'm not so sure I'm going to get black because now it's 1 out of 2. So the probability now is 1 out of 2 that I get black. So notice, when you do that second experiment, this probability depends on what happened here. This probability depended on what happened here. So that's dependent events, where one thing depends on what happens first. But when I flipped the coin, it was not dependent, it was independent. It doesn't matter if I got heads or tails here, this was always going to be 1/2 there. So now think about the question we're trying to solve, where this woman was rolling a die. She rolled it and got a 5, and she wanted to know the probability of getting a 5 next time. Is it the same or different than getting a 5 the first time? Notice, probability of getting black the second time was different than first time. But for flipping the coin, it was the same. Sometimes the probability goes higher, it went up to 100%. Sometimes it goes lower, where it used to be more than 50%, then it went to 50%. So if I roll the die and get a 5, and now I'm going to roll it again and try to get a 5 again, is it the same probability, or does the probability now go up or down? Is it like flipping the coin, or is it like picking the marker? And if you said the probability is going to be the same, you're exactly right. The probability the first time of trying to get a 5 was 1 out of 6, because there's 6 possibilities, and the 5 is only one of them, so the probability was 1 out of 5. I'm sorry, 1 out of 5. 1 out of 6, that's what I meant to say. So there were 6 possibilities, one of them was a 5, you had a 1 out of 6 chance. But then the next time we rolled it, well, there's still 6 possibilities on the die, and still the 5 is only 1, and so it's still 1 out of 6. And so the probability stayed the same from the first event to the second event. Does that mean that the die question was dependent or independent? When you rolled the die and tried to get a 5, the first time and the second time, whoop, dependent or independent? And if you said that those were independent, you're right. So they stay the same.